Hello everybody, today we're going to go on to, technically it's day 3 because we had to merge 2 days, but whatever. We're going to go on to the Compound Inequalities Day. So this is the honors topic. It's very, very new, that's all I'll say. So, get a little lost, it's okay, just write down your question, or where you're getting a little lost, and keep trying it anyway. It's okay if you're not really sure if you're doing it right. That's what trying is, and then we will check it and go over it, and we can correct you if we need to in class. Okay? So let's start with our vocab. So compound inequalities are two inequalities joined together using the word and or the word or. Basically what it's doing is it's giving us two rules to follow to find the solutions to an inequality. It's telling us it can be, as long as it follows this inequality or it follows that inequality, it can work, or it has to follow this one and that one to be a solution. That's the job of compound. So some examples of compounds, you could just have like 3x minus 4 is greater than or equal to 5, or negative x plus 11 is less than negative 2, and we would solve these two to give us our two rules. So like x can be greater than or equal to 5, or it can be less than negative 2. If it follows one or the other, it's a solution. X is greater than negative 3 and x is less than 2. So it has to follow both of these for this example. And the last one would be if it looks like one giant inequality with two signs. So this is actually, when it's merged like this is an and statement. Okay? It's basically telling you the same thing this is, but it's doing it all together. So we will talk about how you can tackle these when we go on to our examples. So, some more notes. When you are solving compound inequalities, it's just like solving a single inequality. I can't talk, guys. It's sad. You need to solve each inequality separately. Okay? And then you're going to use the same word in your answer. So whatever word it gave you in the problem, like or and, you're going to rewrite that word in your answer. Okay? Either and or. If there is no word in the compound inequality, like this guy, we can start solving in the middle and do the inverse operations to both the left and the right side of the inequality. So you don't have to worry about a word for when it's merged like this. We know it's and. But what you could do is just go ahead and do the inverse operation to the variable term in the middle. Just make sure you do it to the left and to the right side on the ends. Okay, and I'll show you an example like that. So example 1, solve the compound inequality, graph it, and write it in set builder notation. So this one says 3x plus 12 is less than 9, or negative 4x plus 3 is less than or equal to negative 13. So I'm just going to go ahead and solve each one. So the first one, I am going to subtract 12 from both sides. I'm just going to work on this one first. So now I have 3x is less than negative 3, and I'm going to go ahead and divide by 3 on both sides. So I get x is actually less than negative 1. That's my first one. Here, I'm going to subtract 3 from both sides, so I get negative 4. There we go. Negative 4x is less than or equal to negative 16. Divide both sides by negative 4, which means I have to flip my sign. I get x is greater than or equal to 4. And I put the word that I had in the problem in my answer. So x is less than negative 1, or x is greater than or equal to 4. So what that means is your solution to this inequality, the value that makes the statement true, is any number that you can have less than negative 1, or any number greater than 4. So there's lots and lots of solutions here. This is why we write it in set builder notation. Now to write this in set builder notation, I'm just going to take my answer and just put the line and the variable in front. So it's a set of x such that x is less than negative 1, or x is greater than or equal to 4. Right? To graph it, I would just graph each inequality. So x is less than 1. I'm going to go ahead and, where did I put these? I can't remember where I put the numbers because I didn't number them all. Here's negative 1, and here's 4 because I'm going to need that later, so I just filled in the rest. You don't really need to fill them in. I don't care that much about numbering a number line, so it's up to you. So now I'm going to go ahead and do this one. X is less than 1, so I'm going to have an open circle on 1, and I'm going to point to everything less than. And then over here, x is also, or can also be greater than or equal to 4, so I'm going to have a filled in circle. Where's my filled in circle? On 4, and I'm going to point to everything greater. So or statements tend to look like this. One section or the other section. Okay? Or they're like going in opposite directions. So you guys are going to try this one on your own. To use step builder notation and graph it. Okay? And we will go over this next class. So our and statements, pretty much if it has the word and in it, it's very, very similar. Like you do the exact same steps with or. Okay? So I'm going to show you two different methods how you can tackle this. One is splitting it up so you have a word in between. And the other method is just doing it together. So I'm going to do method 1 by splitting it up. If I wanted to put the word and in here, I could. I just need to go ahead and split it. So I basically cover up one inequality and the number behind it to get my first inequality. And then I cover up the other inequality to get my second one. So it's -1 is less than a over 9. And then put the and in the middle. And a over 9 is less than 0. So I kind of duplicate the middle and just split it that way. Everybody gets a piece of a over 9. And then I just go ahead and solve it. So for this guy, I'm going to multiply both sides by 9. I get, oh, I forgot to do this one. Do that on this side as well. So I get -9 is less than a, and a is less than 0. Okay? And then I can go ahead and write it in step builder notation. I have to put the a in the front, so I just flip the inequality here. So a such that a is greater than -9 and a is less than 0. Okay? Method 2, when I just solve it together, I'm just going to go ahead and multiply 9 by the middle. Maybe. Yeah, I multiply 9 by the middle. And I multiply both sides on the outside by 9 as well. So that way the 9 will cancel out in the middle. Leaving me just a, and then I just multiply this. So I get -9 is less than a, which is less than 0. So if I was going to write that in step builder notation, I would just write it with the merge thing. This merged one is more often going to be this answer that you would pick, or that you would have for a problem, because it is like all put together. It doesn't have as much writing. Okay? So just be aware, like both of them, I would accept both, but this is more likely going to be an answer choice. Now, to graph it with an and statement, what happens is you're talking about one specific section of the number line that works. So I'm going to fill in my number line, -9, all that stuff 0. Again, you just need the -9 and 0. So using the split up one might be a little bit more helpful to visualize it. So I have to say a is greater than -9. So I'm going to have an open circle on 9. And I'm going to point to everything greater. But it also has to be less than 0. So I'm going to have an open circle on 0 and point to that. So the only numbers that are both bigger than 9 and less than 0 are right here. Okay? So what happens with an and statement is we actually connect those dots. That is the only section. Okay? So using the together kind of, it's very, very visual of what it looks like as the graph. Because you have the -9 on one side, the 0 on the other, and all the possible a's are right in the middle. Okay? Those are the only numbers that will work as solutions. So you guys are going to try this on your own. It's already split for you. I'm going to give you an extra challenge. So you can write it like this with a word, but I challenge you to write it without the word. So smush it together and see if you can do that. Okay? We're going to go over this together in class, but if you have any questions, write them down. We will answer them together, and I will see you guys next time. Bye!